Okay, welcome to example 7 in our functions and graphs topic. We just had a look in example 6 at even functions. I would suggest you have a quick look at that because this is going to be a development of it. So what's an odd function? Well, it's kind of same idea. There's a condition that we have to investigate, that if we were to take some function f of x and we were to consider the negative value negative x, substitute that in, the result would be not the original function f of x, but the negative equivalent. In other words, the negative x produces a negative y value. And if we were to think about that in graphical terms, if I were to, oops, that's a bit squint. If I were to consider points on a graph, say I've got a function, if I were to consider x equals 1 and I've got a certain y coordinate, then if I put negative 1 in, I would expect to get the same distance from the x-axis but in the opposite direction, the negative of that function. So the same would go if x was 2 and say my y value was here, then negative 2 would be the same distance from the x-axis but in the negative domain, and so on. If 3 gave me a negative a y coordinate down here, then negative 3 would produce that coordinate up here. And what I would get would be a function that, if I drew it correctly, would actually have rotational symmetry about the origin, okay? Because it's got that behavior of everything being the opposite of the other. So odd functions have half-turn symmetry about the origin, and again, just consistent with even functions which have even powers of x, odd functions have only odd powers of x. So let's go through a wee proof here. Prove that this function is an odd function. Remember, I was quite passionate in example 6 about how we set out our proof. So first thing I should do is I want to write down what I'm looking for. To prove that an odd function, we can say that the function is odd if, so just basically repeating what I've just written up here, if f of negative x is equal to f of x. So we can go through the process of proving that algebraically. I'm going to write down the original function that I'm given, 2x cubed plus x. And what I'm going to do is to consider f of negative x. I'm going to substitute in negative x, so we'll end up with putting, there's my values of x here, so I'm going to put negative x in each of these spaces. We know that cubing negative x will still give me a negative x cubed value, okay? Negative x times negative x is positive x squared, multiplied by another negative x is negative x cubed, plus negative x is just there. So what I've got here is negative 2x cubed minus x, and if I take a common factor of negative 1, I get negative bracket or negative 1 times 2x cubed plus x, which 2x cubed plus x was my original function. So I've got my original function multiplied by negative 1, which is the definition of an odd function. I'll just move that up a little bit if I can. So we can say here that f of negative x is equal to negative f of x. That's what I defined at the beginning as an odd function, and we can write down, so that's me done my proof. Conclusion, as f of negative x is equal to negative f of x, then the function is indeed odd. And if you notice, when we wrote it down, we've got x to the power 3 and x to the power 1. We've only got odd exponents there in the function. So you can see that even functions have line symmetry about the y-axis, and odd functions have rotational symmetry about the origin, and a lot of functions don't fall into either of those categories. So quite clearly most functions, in fact, are not odd or even. These are just kind of special cases, because when you think about how many times do you deal with polynomial functions that just have either all odd or even exponents. It's not common, so we can't say, unlike numbers, that we can say all integers are odd or even, and there's a whole lot of numbers in the set of real numbers that aren't integers, in the same way that there are a certain number of odd and even functions, but every other one in between is not. Okay, so hopefully that's been helpful, and you can go away and study odd and even functions.